Alright, in this video I am going to be teaching how to multiply fractions. But before I go into multiplying fractions, I want to go over the concept of the greatest common factor. By definition, the greatest common factor is the greatest factor that divides two or more numbers. So, as an example, let's use the numbers 24 and 36. As you can see here, I wrote all the factors of 24. I started from the least to the greatest. Obviously, I'm not going to write 6 times 4 because 4 times 6 is the same thing. So these are the smallest factors, and these are larger factors. So these are all the factors of 24 and all the factors of 36. Now what I do is I want to find the greatest factor. So for example, they have a 1 in common, but that's not the greatest factor. They also have a 2 in common. But is there anything bigger? Well, 4 is bigger. 6 is bigger. But 12 is bigger, and there's nothing bigger than 12. So the biggest factor is actually 12. So then the GCF of these two is 12. You put parentheses around these to denote GCF, but we won't need to know this if you're doing pre-algebra. We just need to find the GCF to divide out the greatest factor when you're simplifying fractions. We'll go over that a little bit later in the video. Now, what I want to talk about is using prime factorization for GCF. Sometimes you'll have really huge numbers and it will be difficult to track the GCF. So this is another way to find the GCF. So for 24 and 36, it's really easy. You can figure out all the factors of 24 and 36. But sometimes there's 3 or even 4 digit numbers where you have to break them up. So there's actually another method to this. Using prime numbers. Prime numbers are numbers that are only divisible by 1 and itself. So for example, 2, 3, 5, 7, 11, 13, 17, 19. Those numbers cannot be divided by anything except for 1 in itself. As you can see, 9 is not there. It's not just odd numbers. 9 is divisible by 3, 9, and 1. It's more than 1 in itself, because the number 3 divides 9. In these cases, it's just divisible by 1 in itself. So let's look at ways where we can write 24 and 36 with prime numbers. Well, let's start out with the smallest. What can you break 24 into? Take out the smallest prime number that you can, which is 24, and 12. Pull out the next smallest prime number you can, you get 6. And then you get 2 and 3. Now, in my other video, I taught how to do exponents. Well, if you look at this, 2 times 2 times 2 times 3, that is 24. You just multiply the bottom branches. So you can rewrite this as 2 cubed times 3 to the first. And for 36, you can do the same thing. Let's do 36 right here. 36 is 2 times 18. Take out this next smallest, 2 times 9, and 3 times 3. So we can write 36 as 2 squared times 3 squared. Now, whenever you're doing the GCF, these numbers are very important because you want the greatest common factor that goes into both of them. So if you think about numbers like 2 and 4, the greatest common factor would be 2. 4 is 2 squared and 2 is 2 to the first. So you're actually taking the smallest power in common. So in this case, for 2, it would be 2 squared. So I'm claiming that the GCF would be 2 squared, and the smallest 3 is 3 to the first. What is 2 squared times 3? Well, that's 4 times 3, which is 12. And if you look up here, the GCF actually was 12. So this is actually a very useful technique for finding GCF for large numbers. So if I do something like this later on, you'll understand why I'm doing it if the numbers are too big. Let's talk about multiplying fractions now that we know how to do the GCF. There are 2 methods to multiplying fractions. Usually, all the time, you can just multiply them straight across. I would recommend multiplying straight across unless the numbers are really difficult. So for example, a times c would be ac, b times d would just be bd. You multiply numerator times numerator over denominator times denominator. And then you simplify afterwards if necessary by dividing out the GCF. The other rule is cancellation rule. I don't know if you can see this, but this is an over b times c over am. As you can see, they both have an a in common, so you can cancel out the common factor in common, and you get nc over bm. And I want to try both rules with you, both the multiplying across and the cancellation rule. So let's look at the examples that I wrote here. Now if I look at it, there's nothing diagonal or anything that I can cancel out. So we'll multiply numerator times numerator. What is 1 times 1? It's just 1. 2 times 3 is 6. Can you reduce this? No. The GCF of 1 and 6 is just 1. You can divide out 1, but you'll still get the same answer. 2. Well, there's 2 ways we can do this problem. First way is just multiply across. What is 4 times 3? It's 12. And 9 times 16 is 144. And right away, what is the GCF of 12 and 144? Well, we know that 12 goes into 12 and 12 also goes into 144, so the greatest common factor has to be 12. We can write out the tree, but it's not necessary. This is going to be 1 over 12. Now, what was another way I could have done this? What is the GCF of 3 and 9? 3. The greatest number that goes into 3 and 9 is 3. So, 3 goes into 9 how many times? 3 times. How many times does 3 go into 3? Once. We do the same thing for the diagonal across. You can also go do top and bottom, but I'll go over that another time. So, 4 goes into 4 once, and 4 goes into 16 4 times. Now this is 1/3 times 1/4, which is 1/12. Same answer. Now I want to go into converting a mixed number into an improper fraction. You see, now we're getting into multiplying mixed numbers. If you see something like this, it's best to do the rule only works for fractions where you have a numerator and a denominator. This has a whole number and a numerator and a denominator. So we're going to convert it to an improper fraction. You multiply 3 times 2 and you add the numerator. 3 times 2 is 6. 6 plus 1 is 7. And keep the denominator, 2. Let's do the same thing here. 4 times 3 is 12. 12 plus 1 is 13. Keep the denominator. And that's how this is how you convert a mixed number into an improper fraction. Multiply, add. Now we can either add across or try to cancel. Well, 7 and 13 are both prime numbers, so I know there's nothing going to go into them. So let's just multiply across. 2 times 3 is 6. And 13 times 7 should be 91. Is that correct? Should be. Yeah. So this is how you would do it. Let's just try some more examples though, just to see some other ways that the problem can be written. For example, if you have 2 over 8 times 3 over 4, for example. Now you can cancel across, but you know 2 over 8 can be reduced to 1 over 4. Again, 2 goes into 2 once, and 2 goes in 8 4 times. It reduces to 1/4. And now I can't cancel, so I just multiply across. 3 over 16. I want to look back on... I want to try one more. Just one more. Suppose we have 21 over 4 times 2 over 15. Well, we can write them out like this. 21 times 2 over 4 times 5. That's essentially what we're doing. and we're gonna show why we divide out the GCF. How can you rewrite 21? Well, it's 2, that's from this 2, and this is 3 times 7. And here is a 15. So this is 2 times 2 times 4 times 5. Now they're written, I broke them up into prime factorization. Actually, you could write this as 2 squared, but I'm not teaching that lesson yet. So the 2's cancel out. And that's pretty much it, except this is actually supposed to be a 3, so the 3's cancel out. 3 times 5 is 15. So the answer is just 7 over 10. And that's pretty much how cancellation works. And so if I look at this, between 21 and 15, the greatest common factor is 3. 21 divided by 3 is 7. 15 divided by 3 is 5. And this goes into 2 once, this goes into 2 twice. 2 times 5 is 10, 7 times 1 is 10. And that's 7 over 10. And this concludes my lesson on multiplying fractions. And I will go into division afterwards. It's pretty much the same thing as multiplication. Thank you for watching.